So here's a practice worksheet for you. We are working with this just one formula for acceleration. Again, acceleration is how fast velocity or how fast speed changes over time. Technically, it's velocity. The change is final minus initial. When you are reading through problems, the main thing that you need to do is to imagine what's going on and then figure out what the numbers stand for in the given. Here's the first problem. A car speeds up from rest of 0 meters per second to 15 meters per second in 5 seconds. Calculate the acceleration of the car. So if you picture what's going on, it's a car. Starts at rest, so it's not moving, and then it speeds up all the way to a certain speed. That certain speed is 15 meters per second. All in all, it takes 5 seconds for that to happen. And what do they want to know? They want to know acceleration. So then you think, okay, what's the formula for acceleration? Final minus initial for speeds divided by time. Final, it's 15. Initial is 0 because it starts from rest. It takes 5 seconds, so your change in time is 5 seconds. 15 minus 0 over 5 is 3. And the units are meters per second squared since we're finding acceleration. The second one, again a car, it's moving at a speed of 10 meters per second. They are asking you how long would it take to speed up to 15 if acceleration that the motor can provide is 2.5 meters per second squared. What you're picturing is there's a car that is moving and it's moving faster because it has acceleration, so it speeds up from one speed to another, from 10 to 15. And they give you the acceleration but want to know how long it's going to take. It's still acceleration formula, final minus initial for speed over time. When you're looking for something that is in the denominator originally, you just swap these two. So change in time would be the change in speed over acceleration. So the change in speed over acceleration. My change in speed was from 10 to 15, so 15 minus 10 is 5. Acceleration is 2.5, so 5 over 2.5 is 2. And we were looking for time, which is measured in seconds. The next one, a little bit harder because, first of all, the acceleration is negative. The car is slowing down. The driver slams on the brakes. They're asking you how fast will it be moving in 5 seconds if it starts at 20. So again, visually, your car is moving at a certain speed. That certain speed is 20 meters per second. And then the driver slams the brakes and the car starts slowing down. And they give you the rate, how fast it's slowing down. Every second, it slows down by 3 meters per second. One of the ways that you can imagine it, it was moving 20. 1 second later, it will be only moving 17 because 20 minus 3 is 17. 2 seconds later, that would be 20 minus 6, only 14. And so you could do this lower school style, 20 minus 3 5 times. Or you're looking back at the formula, acceleration is final minus initial over time, and then if you rearrange this, multiply acceleration times time, that will give you final minus initial, then final is just initial plus acceleration times time. Acceleration times time is negative 3 times 5 is negative 15, and then 20 plus negative 15 is 5 meters per second because we're finding speed. So again, visually, that is very important. You see a car that is moving at a certain speed. That certain speed is 20 meters per second. And then it starts slowing down. For 5 seconds, it keeps losing speed. How much speed is it losing? They're telling you the acceleration is negative 3 meters per second squared, which means that every second it loses 3 meters per second. So 20, 17, 14, 11, and so on and so forth. In 5 seconds, it drops all the way to 5 meters per second. The next part of this worksheet is with graphs. So here we have velocity in meters per second changes over time. And you can see that first, it starts at 0, goes from 0 to 5 in 3 seconds. That's your first part. And it keeps accelerating, but not as much. Then from B to C, it's not accelerating at all because your velocity remains the same, 7 meters per second. Then C to D, our speed starts dropping, and it drops from 7 to 4. And finally, it drops even more. So you can think this is a lot of braking, and then just kind of coming to a full stop with less braking. And the question is find acceleration on each section. So we're going to be using acceleration formula, final minus initial over time, and all we need to do with the graph is just pinpoint final and initial. So from 0 to A, here's our A. Our initial speed was 0, final is 5, so 5 minus 0. And how long did it take? From 0 to 3 seconds, so in 3 seconds. So 5 over 3 meters per second squared. The next one, here we have from A to B, we went from 5 meters per second to 7. So 7 minus 5 is the change in speed. And then as far as time goes, it was from 3 to 6 seconds. So 6 minus 3, it took 3 seconds. So it took 3 seconds to go from 5 to 7 meters per second. 7 minus 5 is 2, 6 minus 3 is 3. So 2 over 3, 2/3 meters per second squared. That's the acceleration over here. Now B to C, you can just look at it and see that there is absolutely no change in speed, hence no acceleration, or do it algebraically. So it was 7 minus 7, it didn't change. The time that passed was from 6 to 10, so that's 4 seconds. 7 minus 7 over 4, 0 over 4, so that's 0 meters per second squared. Now C to D, as I already said, you can see that your speed is going down. You're slowing down from 7 to 4. So your final is 4 meters per second, and initial is 7. And the time that it took was from 10 to 11 seconds. So just 1 second. 4 minus 7 over 1 is negative 3 meters per second squared. And the last one, your last acceleration from D to E is also going to be negative because you went from 4 meters per second to 0. And the time that it took was 5 seconds because you went from 11 seconds to 16. So 0 is your final. You stop completely. Minus 4 over 5 seconds. From 11 to 16, that takes 5. Negative 4 over 5 is negative 0.8 meters per second squared. And that's it.